Cool, let's get started. Hey everyone, my name is Smriti and I'll be walking through question 3.2, which is the second part of the DogsYay problem on the week 4 CSM worksheet. This problem can be challenging, I know, as it explores the new concept of static and dynamic typing, so don't worry if you're a little confused at first. These problems definitely get better with practice, and if you have any questions about any concepts that I go over today, definitely reach out to your CSM mentor for clarification and hopefully they'll get back to you soon. So before we get started and just start jumping into all of these problems, I do want to take a quick second to go over some key terminology that I'll be using today. And so the first is here, if we look at a new object being instantiated called D, dog in front of the D on the left-hand side is the static type of this object, and the dog with parentheses after it, after the new on the right-hand side of the object, is its dynamic type. And so when we call a method, it'll typically be in this format where we have a calling object and then we put a dot and then the method, and then inside the parentheses will be any parameter objects for that method. And so when we're looking at these type of problems, there are some things that we really want to keep track of. The first is the static type of our calling object, the dynamic type of our calling object, which is listed right here, and the name of the method right here. And then we also want to look at the static type of our parameter object. And so definitely don't worry if this was a little fast. We will be going through this several times as we go over each question, but I did want to kind of get this out of the way first before I jump into solving the actual problems. Cool. So let's look at the first part of this question where we have Dan.play Dan. And so now if you're wondering where this Dan comes from, if you actually look over here at the side, I've copy pasted the problem. So here we have two classes, dog and poodle, where poodle is a subclass of dog because it extends dog. And within we have some methods defined. For example, in dog, we have the bark method. And the same method exists in poodle, as well as some other methods are also in poodle. And underneath right here, we have public static void main. So we have our main function. And inside we are instantiating a dog Dan and a poodle Pim. And so here I've highlighted our static types in red. So dog is a static type of Dan, and poodle in blue is a dynamic type of Dan. Underneath, we have that poodle is the static type of Pim, and poodle is also the dynamic type of Pim. Cool, so now that we know that, we can look back at this question over here, where we have Dan.play Dan. And so as I mentioned above, there are some key things that we need to look out for when we look at a structure like this. And so here we have our calling object, which is Dan. Our method, which is highlighted in yellow, is play. And our parameter object is also Dan. So underneath our calling object, we need to keep track of its static and dynamic types. So here I can write down the static type of Dan, which is, as noted here, dog. And the dynamic type of Dan, let's do this in blue, as noted here, is poodle. Cool. And so now we go to the method, and we know the method of the name of the method is play. And then we look at our parameter object, which is also coincidentally Dan, and we just need to look at the static type of our parameter object, which will be, if we look down here, the static type of Dan is dog. So we can just write dog again. Cool. So now when we want to figure out what this is actually going to return, we first need to make sure that this line listed over here will compile. And so to make sure that it compiles, we need to check just the static types. So one thing you really want to remember is that compile time is just static types. So when we look at the static types here, we can basically write this function out as dog, which is a static type of Dan, dot play, and it's taking in a dog, which is also the static type of Dan. So we're just looking at static types here. If we were to rewrite this function just in terms of the type. And so when we look at this function right here, right, dog.play dog, we look at this method. So it's saying that within the dog class, we want to find a play method that takes in a dog object. Well, I look at the dog class over here and I see a bark method, but I don't see any play method. And I don't see any play method where it takes in a dog. And so since the static type doesn't work, So we don't have a play method in the dog class. This is actually going to be a compile error because this function would not, this call would not execute. So I'm going to say compile time error. Cool. And so now we can move on to part 2 of this problem, which is dan.playPim. And so we're going to follow the same structure here. And you'll notice I do this for every single problem. So if you just follow these steps, you should be good on any like similar question. If you just remember the steps that you need to go through and do it methodically. And so here we see Dan over here. We look at its static type, which is dog. And then we look at its dynamic type in blue over here, which is poodle. The method's name is, again, play. And then we look at, oh, now it's taking in Pim as a parameter object. And so we just need to look at the static type of Pim, which is poodle. Cool. And so now we can rewrite this expression in terms of just the static types for compile time, because compile time only checks static types. So if we were to rewrite this expression just in terms of its static type, the static type of Dan is dog. So I can put dog dot play. And the static type of Pim is poodle. So dot play poodle. So here you might have guessed, but we are running into a very similar question or issue as before. Dog simply does not have a play method. And so whether you pass in a dog or a poodle, it doesn't matter. This is still going to be a compiler because it doesn't have either of these functions. And so, yeah, we don't even get to runtime. It's just going to error in compile time, and we're going to get a compile time error here as well. Cool. So why don't we move on to the third question, which is pim.playDan. So now we see that our calling object is Pim. So just going through the motions again here. We look at Pim down here. The static type is poodle. Pim's dynamic type is also poodle because we see that right here on the right-hand side. It's taking in the parameter Dan. So the parameter object, its static type is dog. And the name of the method is play. And so now we can rewrite this in compile time as we did before. So the static type of Pim is poodle. So poodle dot play. The static type of the parameter object is dog. So dot play dog. Okay, cool. This is more interesting because we see that our poodle actually has play methods. So now we can actually try to figure out what we want to do in runtime. And so now we see that poodle, I go to this poodle class right here. I see play. I see two play methods. There's one that takes in a dog and one that takes in a poodle. So this checks out because there is a play method in the poodle class that takes in an object of type dog. So compile time, this is going to compile. Now we can get to the more interesting case of runtime. So the two things that we're going to look at in runtime is the static. So poodle dot play dog. But one more interesting thing that we can look at is also the dynamic type. So dynamic type only comes into play in runtime, and we're only going to check the dynamic type of the calling object. So here, the dynamic type of the calling object is also poodle. So when we look at dynamic type, it'll be poodle.play, and it's going to take in a dog object. And so there's no difference here between the expression written in static type and dynamic type. And so we're just going to execute what's under, we're just going to execute what's under this class where play takes in a dog object. And so here we see that it says system.out.println no. And so I'm going to print no. And that's what's going to be executed here. Actually, it wouldn't be executed with the quotes since you're just printing it. So it will print the string no. And that is the answer to this part. Cool. Let's move on to 4. So here we have pim.playPim. And we see that pim is our calling object, and pim's static type is, let's change this to red here so that it matches. The static type of pim is poodle. The dynamic type of pim is also poodle. I keep using the wrong type of blue. I apologize for people who care about that. That is bothering me as well. So here we have poodle as a dynamic type. And then the parameter object is also pim. So we've already seen that the static type is poodle. So I will write that again. Cool. So now when we go to compile time, let's do what we've been doing for the past couple parts and check whether this will actually compile. So let's like write out the static types. So we have poodle.play, and it takes in a poodle object. Cool. So does poodle have a play method? It does. I see two. And does it have one that takes in a poodle object? It does. Cool. So this is going to compile. We'll also get our runtime. Our runtime is going to, we first have our default compile time. So we always are going to check this, right? We've already checked this. It works. Poodle. And our dynamic type is also poodle. So here we actually coincidentally are having the same expression for a dynamic type. So poodle.play poodle in our runtime. And since these are both the same, I'm going to execute poodle.play poodle, which is this function right here. And I'm going to print bow wow. So if you're wondering why I am checking this dynamic type, in this case, it turns out that the static and dynamic type of pim are the same. But if the static and the dynamic type of pim were not the same, then let's say the dynamic type of pim was something different. Then we would be able to go into, if this were different, I would first check whether I had a play method that takes in a type poodle. And if that is true, then I would execute that function. If that function does not exist, then I would default to the static type function right here. So since they're the same, that actually doesn't really show up here, but maybe we'll see it later on. Okay, cool. Let's move on to 5. Pim, calling object. Bark is the name of our function. Ooh, there's a different function here. Dan is our parameter object. The static type of pim is poodle, right here. The dynamic type of pim is also poodle. The static type of Dan, I'll highlight that right there. Static type of Dan is dog. Solid. Okay, let's move on to our compile time. So here we have just a static type, so poodle dot bark of type takes in a type dog as the parameter object. Cool. Does this check out? I see here that I do have bark methods, and I do have a bark method that takes in a type dog. And so compile time is going to compile. And so now I'm going to look at my runtime, which is the same. So here we can write down our default, which would be the static. And now poodle.bark dog. And so here we have the same thing for our runtime because the dynamic type is also poodle. So I'm going to write down poodle.bark dog. So it's the same function, and I'm just going to execute this method, which prints out woof. Cool. Let's move on to the next question, which is problem 6. We're almost there. I think there are, including this one, 3 more. So pim is our calling object, .bark pim. And so as we've seen before, the static type of pim is poodle. And so is the dynamic type. And the static type of pim, again, and the parameter object is poodle. All right, so let's move on to our compile time here. So we can say poodle.bark poodle. And then in our runtime, we're going to write down our static first. So this is our default. And then we'll check whether dynamic type actually has it. And here, since the dynamic type is the same, it's just going to be the same. So poodle almost spelled poodle wrong there. Dot bark, takes in type poodle. And so what is this going to print? Poodle dot bark poodle. It's going to print yap. So since I found this method right here, so it's going to print yap. Cool. Moving on. Now we have our calling object is Dan. And so this one is going to be a little more interesting because our static and dynamic types are actually different for Dan. So our static type for Dan is dog, and our dynamic type for Dan is poodle. And now when we look at our parameter object, which is also Dan, we only want to look at the static type of our parameter object. So the static type will again be dog. And the name of our method is bark, highlighted in yellow there. All right, so now let's go to our compile time and let's write down our static types. So dog dot bark dog. Does this function exist? So I'm going to go to my dog class over here. I look, there's only one function in there and it has a bark and it takes in a type dog. So yeah, it exists, it works. So this is gonna compile. And now I'm gonna go to my runtime. So here, my default, which is our static type, is dog.bark dog. But I'm gonna first check whether our dynamic type has something. So the dynamic type of Dan is poodle. So poodle.bark dog. So what I'm gonna do here is first I'm gonna go to the poodle class and check whether it has a bark method. If the poodle class has a bark method, I'm gonna execute this line. If it doesn't, then I'm gonna default to my static type and execute this line. And so you'll see that I actually, when I go to my poodle class right here, I find a bark that passes in a dog, and so I can execute this line. And so it works. I don't have to default to the static types. So I can actually just use the dynamic types here and print out woof. Yeah, so if any part of that doesn't make sense, definitely reach out to your CSM mentor, but hopefully we hadn't really seen this case before in the other ones because the dynamic and the static types of PIM were the same. But here we see why in runtime we need to even check the dynamic type, because if it's different, we'd want to default to our dynamic type. Cool. Let's move on to the last question, which is dan.bark PIM.